And the first one is solve the set of simultaneous equations, and it may not seem as a elusive polynomial question, but actually it is. And the target here is to construct a cubic equation having roots a, b, c. And actually then after you construct this cubic equation, you can solve it to get a, b, and c. And that's actually solving this set of simultaneous equations. So the generic form of a cubic equation, as I discussed in the previous video, is actually x cubed minus sigma alpha, but here is actually a, b, and c, so sigma a x squared plus sigma a bx minus abc is equal to 0. So now let's discuss the information that we have. So what we actually have is the following. So we have sigma a, that's actually 4, sigma a squared, that's 14, and sigma a cubed, that's 34. So what we require, we need sigma a. Actually, you can deduce that from the cubic equation format. So as you can see, we clearly need sigma a, and we have that already. We also need sigma ab. We do not have that yet. And also we need abc. So we have to find that first. So we require sigma a, sigma ab, and abc. So step 1 is to find sigma ab. So as you can remember, from the sum of the squares of the roots, actually you can find sigma ab. So sigma a squared is actually equal to sigma a whole thing squared minus 2 sigma ab. So substitute the values, that's 14 is equal to 4 squared minus 2 times sigma ab. So just subject sigma ab, and that implies that sigma ab is actually equal to 1. That's 1. So we have sigma a and sigma ab. So now let's find find abc. So if you can remember, from the sum of the cube of the roots, you actually can find abc. So let's find that now. Sigma a cubed minus 3 times abc is equal to sigma a times sigma a squared minus sigma ab. So just substitute, and actually you can find abc. Sigma alpha is 4, sigma a, and sigma a squared is 14, and sigma ab, we found that that's 1. And subject abc, and you find that it's actually equal to minus 6. So let's plug these values into that cubic equation format. So let's substitute them. X cubed. So we have sigma a, that's actually equal to 4. So minus 4x squared plus sigma ab. So sigma ab, we found that that's actually equal to 1. So plus x minus times minus 6 is plus 6 equal to 0. So now let's solve it. And I assume that you obviously know that solving this is very easy. So use a let f of x is equal to x cubed minus 4x squared plus x plus 6. And by trial and error method, you actually find out that f of minus 1 is actually equal to 0. So that implies that x plus 1 is a factor of f of x. And then perform long division and find the quadratic equation and factorize that, and you have the answers a, b, c. It can be in any order. We do not know that. So the roots or a, b, c after long division and factorization are the following, and those are the answers. So the roots are -1, 3, and 2. So that's it. You solve those simultaneous equations. And let's move on to the second question. Okay, the second question. Okay, please read it and pause the video and attempt it first, because this is one of the best questions that appear in a Cambridge paper. So sigma alpha is actually equal to -1, and sigma alpha beta is c, and sigma alpha beta gamma is -4, and alpha beta gamma delta is -2. So now let's do part 1 first. So they say use a substitution, but usually they do give it, but in rare cases they may not give it. So please practice it. X is equal to 1 over y, so substitute for x in that original equation. What of y? -2 is actually equal to 0. So then simplify that, and you'll see that y to the power of 4, so -2 times y to the power of 4 plus 4 times y cubed plus c times y squared plus 5 plus 1 is equal to 0. So you multiply by -1 to make it nicer. And let's label this equation star. It's good common practice. So this quadratic equation has roots 1 over alpha, 1 over beta, 1 over gamma, and 1 over delta. To make things easy, you let 1 over alpha equals to lambda, and 1 over beta equals to mu, and so on. So it's easy to manipulate later on. So now you know that equation star has roots lambda, mu, and so forth. So for star, let's apply the sum of the roots. That's actually equal to 2 and sigma lambda mu, and that is equal to minus c by 2, and so on and so forth for the other two. It's going to be half, and the product is actually equal to minus half. So now the second part they tell to find is alpha squared plus beta squared plus gamma squared plus delta squared. That is sigma alpha squared, and the other one is sigma lambda squared. So let's find that out. So sigma alpha squared, using our normal formula, sigma alpha squared is actually equal to sigma alpha whole thing squared minus 2 times sigma alpha beta. So substitute and find that. That's actually equal to 1 minus 2c. And sigma lambda squared is sigma lambda whole thing squared minus 2 times sigma lambda mu. And substitute values for that and find sigma lambda squared. That's 4 plus c. And let's do the third part. And they tell to find this alpha minus 1 over alpha squared and so on and so forth plus. So let's consider just one unit and see. Let's expand one unit, and also actually let's consider the last one also, delta minus 1 over delta whole thing squared. So the third part actually has 3 alpha minus 1 over alpha squared plus dot 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 delta minus 1 over delta squared. So just expand this alpha squared minus 2 times plus 1 over alpha squared plus so on and so forth delta squared minus 2 plus 1 over delta squared. So actually, if you observe very carefully, this is actually equal to sigma alpha squared plus sigma lambda squared minus 8. So substitute the values. We found that sigma alpha squared is 1 minus 2c and sigma lambda squared is 4 plus c. Simplify to get minus 3 minus c. Alright, so let's move on to the fourth part. Quite an interesting part. That's the best part for this question. Alright, not all real. So at least one complex conjugate pair is there. So let's use a different approach, proof by contradiction. So let's assume that alpha, beta, gamma and delta are actually real. And then let's contradict it to show that they are actually not all real. Alright, assume that all four are elements of the real set. Just assume it. Let's contradict it later. So take a look at this. We found that this result is actually equal to minus 3 minus c, right? So if you substitute c as minus 3, actually you find out that actually it's equal to 0. And now we assume that all are real, right? So if in fact all the roots are real, this must imply that each one of these alpha minus 1 over alpha squared and so on and so forth must be equal to 0. That's the only way that's equal to 0 if all are real. So let's find out. If each unit is actually equal to 0, that will be the only way if alpha, beta, gamma are elements of the real number set. So that this actually implies that alpha minus 1 over alpha whole thing squared is equal to 0. Beta minus 1 over beta whole thing squared is equal to 0. And so on and so forth. So alpha minus 1 over alpha is equal to 0. This implies that alpha squared is actually equal to 1. And beta squared is equal to 1. Gamma squared is equal to 1. And delta squared is also equal to 1. And then, if you observe very carefully, alpha squared plus beta squared plus gamma squared plus delta squared is actually equal to 4. Because 1 plus 1 plus 1 plus 1 is equal to 4. Is in fact equal to 4. But we found out that sigma alpha squared is 1 minus 2c there. So if you substitute c as minus 3, you get 7. So you get sigma alpha squared is 7, and then you also get sigma alpha squared is equal to 4. So 7 is not equal to 4. So this is a contradiction. And then you can properly say that not all roots are real, and there is at least one complex conjugate pair. And that concludes the video, and let's meet in the next video. We will be talking about summation.